Okay, good evening. This is Rishikesh. So today we are going to solve a problem from Codeforces. This is 1244C, the football season, and the question goes like this. The football season just ended in Berlin. According to the rules of Berlin University, each match is played between two teams. The result of each match is either a draw or a victory of one of the playing teams. If a team wins in the match, it gets W points and opposing team gets 0 points. If the game results in a draw, both teams get D points. The manager of Berlin Capital team wants to summarize the results of the season, but unfortunately, all information about the result of each match is lost. The manager only knows that the team has played N games and got P points for them. If you have to determine three integers x, y, and z, the number of wins, draws, and losses of the team. If there are multiple answers, print any of them. Okay, so here we have to take the input of four integers, that is n, p, w, and d as input. That is the number of games, the number of points they have lost, and the number of wins, the number of points they will get if they win, and the number of points if the match results in a draw. Now also we have to take a look at this condition that the W would always be greater than D. That is, the number of points avoided for winning is strictly greater than the number of points that is awarded for a draw. Now the expected output can be -1 if we don't find three numbers x, y, z such that it satisfies the condition, and else we have to print x, y, z, that is the number of wins, draws, and losses of the team. If there are multiple possible triples of x, y, z, then we have to print any of them, and the number should meet the conditions, that is x into y plus y into d should be equal to p. That is, the total number of points should be satisfied by the number of the points that is received when they win, and the points they get when the match results in a draw. And x plus y plus z should be equal to n, and that is quite intuitive. um, okay, so here we can conclude that for a particular case we can have infinitely many solutions. We take the code, that is, here we take as the given input n comma p comma w comma d in one single line, and that is very required, since it's if we look at the sample input and output, we have to take all the four numbers in one single line. So here, using the map function, we have taken the input of n comma p comma w comma d, and here we have we have assigned x equal to p divided by w. So here we are actually trying to find the maximum number of wins that the team can have. Now, so basically x would always start from the greatest possible value that it can take. Then here we run a loop for and y, as we know, is the number of match that is drawn for the team, and here we run it from 0 to w. So basically from x we are trying to reduce reduce x by using y. Now x can be reduced, or else it would be the same value as p divided by w. That we'll see how we are finding out that. So this runs from y to w. So here one thing that we have to note is that y would always be less than w. Since we are trying to maximize x, we get some remainder, and now this y could never be greater than W. That is one thing that we have to note. That is the crux of this problem, as we can see here. And since and in this for loop, it gets into the condition that is y into d minus p modulus w. Modulus w should always be w. So y into d, that is the number of points they get in into d, minus p modulus w, that is if there is any remaining points that the team has after um, like if we see that if p is not divisible by w, then we have some remaining points. We reduce that with y into d, and we see if it's divisible by w. Now if it's it's divisible by w, then we know that there is some value y that would satisfy the equation, that is x plus y plus z equal to n. And also here n is a value that is arbitrary. That is, if we get the value of x comma y, then intuitively we can subtract x plus y from n and find out the value of z. So this condition, if it meets the condition, that is y into d minus p modulus w, and if it's completely divisible by w, then we subtract this value, that is y into d minus p modulus w, from x, and that would reduce the number of wins, and hence we get a particular value for y. Now this could be 0, or this could be somewhere in the range of 0 to w, and hence we calculate z from n minus x minus w. Now here we then enter a if statement, that is x plus y less than or equal to n. As I have said, here we only have to find the value of x plus y, then intuitively we can find the value of z, hence to satisfy the condition, that is x plus y plus z. And here, as we also have discussed, x would always be less than w, and also from the given constraints we understand x should be greater than or equal to w, greater than or equal to 0. And here, since we are subtracting the numbers, there can be cases where x would go in negative without following this condition, hence the constraint like this, and x into w plus y into d would always be equal to p. That is given to us in the question itself, and if this all conditions are met, then we print x comma y comma z, else we print -1. Okay, so here the approach was quite normal, as we can see. Now let's see some of the test cases that have been provided to us, and see if it works. Okay, so here we have inputted 30 comma 60 comma 3 comma 1, that is 30 number of matches, 60 points, 3 and 1. So here if we try to do the math, if we see 60 points and we have 3 points if we win, so if we divide 60 divided by 3, we get 20. So 20 matches can be won, and also hence since 60 is divisible by 3, we won't have any cases where we see a draw. And also if we subtract n minus x minus y, then we get z equal to 10, and if we add x plus z plus y, we get the answer as 30 itself, that is 20 plus 0 plus 10, which is equal to 30. So okay, and here we get an output just like this. And so if we input 10 comma 51 comma 5 comma 4, then the expected output has to be -1. Let's see what happens here. So here I paste it and we run, and it's running, and we get the output as -1. Now 20 0 15 5, we paste it, and the output is 0 0 20. As we can see, since there are 0 number of points it's intuitive that the number of losses we won't win or we won't draw the match. So now let's try to submit this code. The problem is 1244C. We paste our code here and submit. So as we can see, the code is running. We'll see if so it's already on test 12. We can see if what are the previous test cases that we say. As we can see, the numbers, the solution is working fine. And okay, so it's already has passed test. It's on test 20. It's on test, and as we can see, it's accepted. So this was the problem, this status, and as we can see, so there are a lot of test cases. There are 70 test cases for this, and the code has passed all of them. So that is it. The code works for this problem. A very simple problem, yet it can be a bit confusing, since if we the trick, the crux of the problem, that is x has to be less than w, and if we find that, we can do this question pretty easily. So thank you, that is it from my side. Thank you.